Now let's discuss about the zeolite softener. This is also called as base exchange or cation exchange process. This is used for the removal of permanent hardness. Now these zeolites which are used as cation exchange resins, these are either natural or they can be synthetic also. And these are base exchange hydrated silicates of sodium and aluminium, and they have got a general formula Na2O Al2O3X SiO2 YH2O. The usual value of X is 2 or more and that of Y of ranging amount. Now these zeolites, they have got an excellent property of exchanging their cations, and therefore during the softening process the sodium ions of the zeolite, they get replaced by the calcium and the magnesium ions which are present in the hard water, right? So the chemical reaction which is involved is given below here. So you will understand what do you mean by exchange of ions. Now here Na2Z, this is the sodium zeolite or an active zeolite, and the Z stands for the complex zeolite radical, right? So we will simply call it as sodium zeolite. Now the salts which are giving permanent hardness in the water, as you know, is calcium bicarbonate, calcium sulfate, calcium chloride, magnesium bicarbonate, magnesium sulfate, magnesium chloride. So all these salts, both carbonate and non-carbonate hardness, both temporary and permanent hardness, all the salts are going to give both the types of hardness in the water, right? So these are present in the hard water. Now what is going to happen is these ions, they simply get exchanged with the sodium ion of the zeolite. So now what is going to, after the reaction, here it is not a chemical reaction, it is only exchange of ions. So after the exchange of ions, what you will get is, instead of sodium zeolite Na2Z, you will get Na2HCO3 twice, Na2SO4 and Na2Cl2. That is sodium bicarbonate, sodium sulfate and sodium chloride. And the ions which are present in the water, they get exchanged with the resin or the zeolite. So you will get calcium zeolite and magnesium zeolite, right? So here it is a sodium zeolite or an active zeolite which is used for exchanging of the cations, and these are calcium and magnesium salts which are giving permanent and temporary hardness in the water, and these are sodium salts which are formed by the exchange of ions, and these do not cause any hardness in the water. And this is what calcium or magnesium zeolite, those which are exchanged or used zeolite, right? So this is how the exchange of ion is going to take place, right? Now the calcium and magnesium zeolite which is formed here, after some time, all the zeolite is complete, the sodium zeolite completely gets converted into calcium and magnesium zeolite, and the process of removal of these ions or exchange of these ions will stop once all the sodium zeolite gets converted into calcium and magnesium zeolite. Then you may have to, or you have to regenerate it back into this calcium and magnesium zeolite should be once again regenerated back into sodium zeolite, right? Because it gets exhausted, all the ions get exchanged and there will not be any sodium zeolite left. So therefore you have to regenerate it. So this is regeneration is a very simple process. The calcium and magnesium zeolite can be regenerated into once again active sodium zeolite by treating it with 5 to 10% solution of simple sodium chloride, right? The salt sodium chloride which we are using every day, 5 to 10% solution of sodium chloride, right? You have to pass through the zeolite, and once again the ions are going to get exchanged and you will get back the sodium zeolite. Now this regeneration reactions are shown here, you will understand. Now here the calcium and magnesium zeolite is formed, this calcium and the magnesium zeolite which is the used zeolite. You are treating it with 5 to 10% of sodium chloride or sodium chloride solution, and again once again the exchange of ions will take place, and once again you will get the sodium zeolite, that is the regenerated zeolite, and again calcium and magnesium chlorides are formed. The zeolite softener or the cation exchange unit resembles a sand filter in which the filtering media here is zeolite instead of sand. Now the hard water enters through the top and it is evenly distributed on the entire zeolite bed. Just like the filter bed, you have zeolite bed. So hard water is allowed to pass through the zeolite bed, and the soft water is collected through the strainers at the base, right? And when significant portion of the sodium in the zeolite is replaced by calcium and magnesium, it is regenerated by washing it with first clean water, by reversing the flow, and then by treating it with 5 to 10% solution of sodium chloride or brine, that is the salt solution, right? So the excess amount of brine solution which is retained in the zeolite after the treatment is removed once again by washing it with good quality water. Then the regenerated zeolite can be used again for water softening, right? Now these zeolite softener can either be gravity filters, just like gravity filters, or they can also be just like pressure filters, right? Now there are some advantages and disadvantages in the method. Advantage is the water of zero hardness is obtained, right? All the calcium and magnesium is completely replaced by the sodium. Therefore you will remove all the hardness causing salts from the water. Therefore you will get zero hardness. Therefore it is very useful in textile industries and boiler feed water requirements, where they prefer water with very low hardness or water with zero hardness. And the softener plant is very compact, automatic and easy to operate. And here, because there is no chemical reaction, no precipitate produced, nothing here, only it is simply exchange of ions. Therefore no sludge is formed, like in the lime soda process you see a lot of precipitate, so a lot of sludge is produced. So here no sludge is produced and there is no problem of sludge disposal. The running maintenance and operation cost is also quite less. It removes iron and manganese from the water, and there is no difficulty in treating water of varying quality. There is no problem of pipe incrustation of the distribution system as in case of the lime soda process, right? In the lime soda process, pipe incrustation will take place. The pipe incrustation is what? Deposits of this precipitates of magnesium hydroxide and calcium carbonate. So that precipitate, if it is not completely removed in the sedimentation tank provided after the softening, some small portion of that gets carried away, comes out of the tank, and it gets deposited in the filter tank or in the distribution system. That is what we call as a pipe incrustation. So that problem is not there here because there is no precipitate at all, right? Disadvantages: not suitable for treating highly turbid water, because the turbidity and the suspended impurities, they can get deposited in the zeolite particles and cause obstruction to the working of the zeolite, right? It is just like a filter. If water is turbid, it starts blocking the filter, no? Just like that. And some amount of sodium bicarbonate is left in the water after the zeolite process is over, right? So sodium salts, right? These are all produced. So these sodium salts are left in the water, sodium bicarbonate, which causes foaming in boiler feed water or in industrial water, right? And zeolite processes are costlier, unsuitable for treating water containing iron and manganese, right? What is the problem with iron and manganese is, iron zeolite and manganese zeolite are produced when you are using it for the removal of iron and manganese, right? Like in the earlier calcium zeolite and magnesium zeolite, here iron zeolite and manganese zeolites are produced. Now, unlike the calcium and magnesium zeolite, which can be regenerated by passing sodium chloride, here you cannot regenerate, right? Iron zeolite and manganese zeolite formed during the chemical or during the exchange process cannot be regenerated into sodium zeolite by passing sodium chloride in it. Therefore, the zeolite is completely wasted. Even though it helps in the removal of iron and manganese, but you have to throw away the zeolite after every cycle. When all the zeolite gets converted into iron and manganese zeolite, you have to throw away the zeolite and use a fresh one. So that is why it becomes very costly for treating water containing iron and manganese, right? Now this is a simple figure which looks just like a pressure filter. This is a zeolite softener. Hard water inlet is there, it comes into the tank, passes through the zeolite, gets collected in the collection system and is taken out. And when after some time, when all the zeolite resin gets converted into calcium and magnesium zeolite, you have to regenerate it using a brine solution or a salt solution that is added, and that salt solution is allowed to percolate through the zeolite bed, and then later on it is, once it gets back converted into sodium zeolite again, you can restart the inlet here, and once again the softener plant will start working. So this is how a zeolite softener is going to work. So this is also a short note question in the exam. Okay.